Okay, we are skipping chapter 6 and moving right in to chapter 7. Chapter 7 is quadrilaterals and polygons. Okay, that is what chapter 7 is all about. And then 7.1, we are just talking about the angles of these polygons. Okay, we're going to be starting in GeoGebra, mostly because we have to draw a quadrilateral and a pentagon. Remember, what's a quadrilateral? Just as a refresher, it's a four-sided figure, right? And a pentagon is a five-sided figure. Okay, so just so we're aware, a little refresher there. We're going to be drawing those in GeoGebra. And then we're going to be finding the sum of the interior angles. And then we're going to be plotting them down in here. Before we jump over to GeoGebra, I want to ask a quick question. And that question is, what's the sum of the angle measures when we have a three-sided figure? Okay, so we're talking triangle. What's the sum of the interior angles? Remember, it's 180 degrees. Those interior angles add up to 180 degrees. We're going to be talking about figure with 4 sides, 5 sides, 6 sides. We're going to be coming up with rules for that. Okay, so let's start with the quadrilateral. You guys might already know some of the interior angles of a quadrilateral, but we're going to prove it right here. So let me just draw any four-sided shape. Okay, does not matter where these go. Okay, there's a four-sided figure. We're going to be finding the interior angles. So let's find these angles quick. And then let's add these angles up. Okay, I just want to make sure I can read these all clearly. Now let's add these. We have 47.7. I'm just adding the old-fashioned way. You guys can grab a calculator and add if you'd like. And then 139.4. Okay, let's add these up. Well, I can do this actually pretty quickly. I know that 7 and 3, that's 10. And 6 and 4 is 10. Well, 10 and 10 is 20. Okay, that was quick math for me. You guys can do it a little differently if you'd like. 2 and 7 is 9. 9 and 2 is 11. 11 and 9 is 20. 2 and 4 is 6. Plus 1 is 7. Plus 6 is 13. Plus 3 is 16. And then 1, 2, and 3. Okay, so the interior angles of a quadrilateral add up to 360 degrees. Okay? We probably already knew that. Let's go back to our table here, and let's write that down. 360. Okay? Now let's find a five-sided figure. Let's find the interior angles of a five-sided figure. First, let's just start from scratch. Let's delete all of this. Delete each one. Let's create a new five-sided figure. Oh, give me 1 second. Okay, doesn't matter. I'm just creating a five-sided figure somewhere. Here's my five-sided figure. Okay, now let's find the angles. Oh, there we go. And then let's add all of these angles up. Okay, I want to make sure I can see all my angles clearly so I don't make any errors here. I can see them all pretty clearly. Now I'm going to add them again. Okay, just the way I did the last one, the old-fashioned way. 105.3, 142.1, 74.7, 116.6. Oh, not 116.6. And then 103, or no, 101.3. KDWB. 101.3. Okay, now we're going to add these together. Great. I know this is 4, and 4 and 6 make 10. And I know 7 and 3 make 10, so 10 and 10 is 20. 2 plus 5 is 7, plus 2 is 9, plus 4 is 13, plus 6 is 19, plus 1 is 20. And I know 2 plus 4 is 6, plus 7 is 13, plus that 1 is 14. And I have 1 plus 1 is 2, plus 3, 4, 5. So we get 540 degrees. So let's mark that, 540 degrees. Now, we want to plot our table, plot data from our table in a coordinate plane. It wants us to go through and find a 6-sided figure, 7, 8, 9. I'm not going to go through that. I only want to go through the quadrilateral and the pentagon. Now I'm just going to plot these, okay? So down here is going to be my number of sides, and this is going to be my sum of angles. Okay, so if I start here, and I say this is 3, this is 4, 5, 6, 7, 8, whatever it may be, and I know that I start at 180, and so 180, 360. What's the difference between these two? 180 to 360. What's the difference? 180 degrees, right? 180 plus 180 is 360. What's the difference between 360 and 540? 180 degrees, right? Hey, we're going to add up all these. Okay? All by 180. What's 540 plus 180? Grab your calculator. 540 plus 180, 720. Hey, I don't even need to do that. Plus 180, that's 900. Plus 180 is a 1080. And then plus 180 again is a 1260. Okay, so they're each going up 180 degrees. Okay, so I know that this is 540. Right, so, and I'm going to get a graph that looks just like this. It's a linear graph, right? It's a linear graph. Goes up in this direction. So, knowing what we know, let's scroll down. Let's try to find a function that fits the data. Okay? I want you guys to try to come up with a rule. Try to think of a rule. Okay? And I'll give you a hint. We're going to be multiplying 180 by something. Okay, that's our general rule for finding the angles of any polygon. Starts with 180. Okay? Well, let's start with this. What do we know about a triangle? A triangle has 3 sides, right? So here, let me draw, maybe go to the side here. We know that a triangle has 3 sides, and it's 180 degrees. So we know that 180 has to be multiplied by 1 to find a triangle, and that's 180, right? A quadrilateral has 4, and it's 360. Okay, so well, we know that this has to be multiplied by 2. And that's going to equal 360. 360. Okay. And we know when we have 5, it's going to be 540. Yeah. So we know that when 180 is multiplied by 3, we get 540. So what is our general rule for any polygon? How can we find any polygon? Well, it has to do with the number of sides. That's what's going to go in our parentheses. But it's written like this. Okay? 180 times n minus 2, where n is equal to the number of sides. So, for example, if we have a 5-sided figure, we're going to take 180 times 5 minus 2, which is equal to 180 times 3, which is equal to 540. Okay, so there's our general rule for finding the sum of the interior angles of any polygon. That's exactly what we did there. Okay, now use the function you found in expression 1 to write a new function that gives a measure of one interior angle of a regular polygon. Oh, so we want to find one interior angle of a polygon, a regular polygon, That's important. A regular polygon means that, a little refresher again, a regular polygon, all angles are congruent, okay, in the polygon. So for an example, let's try to figure this out. If we have a 3-sided figure, we have a triangle. So we have a triangle. Okay. Find the measure of one interior angle using what we've used in explanation 1. So we said that 180 times n minus 2 is how to find the measure of the interior angles, the sum of the interior angles. Okay, but we only want to find one angle. So if we say, well, if we said 180 times 3 minus 2, we're working with a triangle, that equals 180. How do we find the measure of one angle? We divide it by 3, right? Because there's 3 angles, 1, 2, and 3, which equals 60 degrees. Well, what if we set a 4-sided figure? We'd have 180 times 4 minus 2, which equals 360. But how would we find the measure of one angle? We have to divide it by 4, right? So our rule to find the measure of one angle, same rule, 180 times n minus 2, but we're dividing by n, where n is the number of sides. Okay? Part B says use the function in part A to find the measure of one interior angle of a regular pentagon. Use dynamic geometry. We don't need to use dynamic geometry. We don't need to use GeoGebra. Let's just do this. Let's practice. Okay, pentagon. That's a 5-sided figure. So we're going to have 180 times 5 minus 2. We're going to divide that by 5. Okay, so that equals 180 times 3 is 540. Okay, we did that. Divided by 5. Okay, simply grab your calculator. If you can't do that in your head, I can. I'm using my calculator. 540 divided by 5 is equal to 108. So the measure of one angle, oh, not 180, I'm sorry, not 180, 108. So the measure of one angle in a regular pentagon is 108 degrees. Part C. Okay. Sum of the measures. Well, we know that 3 is 180. And 180 divided by 3 is 60. No, 4, we have 360. Okay, and 360 divided by 4 is 90. 5, we just did that one. It is 540 and 108. 6 is 720. Divide that by 6, we get 120. Our 7-sided figure is 900, and 900 divided by 7 is 128.57. And then we have 1080 divided by 8, that's 135. And lastly, we have 1260. Divide that by 9, and we get 140. There's our table. Part 3 says, what is the sum of the measures of the interior angles of a polygon? We already talked about that. We have 180 times n minus 2, where n is the number of sides. Okay? Find the measure of the one interior angle. Okay, so we need to find one interior angle of a regular dodecagon, which is a polygon with 12 sides. So we need to apply our rules here. We need to apply our rule of one angle. Okay, I'm going to scroll down, giving myself some room. So we remember our rule for one angle is 180 times n minus 2. Yeah, that's to find the sum of all of them. Then we have to divide by the number of sides. Okay, where n is 12. So let's plug those in. We have 180 times 12 minus 2 divided by 12. Grab your calculator. I'm going to. 180 times 10, we can do that in our head, right? We have 1800. So 1800 divided by 12 is 150. So 150 degrees is the measure of one angle in a 12-sided figure, in a regular 12-sided figure. That's important to know. It's a regular 12-sided figure. All right, moving on. A few notes here. A few notes to jot down or maybe do, write them in your own words. Okay. A diagonal is a segment that joins two non-consecutive vertices. Okay, for example, I drew a figure over here. No, that's terrible. Bad drawing. Okay. A diagonal would attach two vertices. Okay, there's a diagonal there. Here's another one in blue. That one here. Okay. Just any two non-adjacent or non-consecutive vertices. An equilateral polygon is a polygon with all congruent sides. Polygon with all congruent sides. Okay, so each side is the same length. An equiangular polygon is a polygon with all congruent angles. And a regular polygon is a combination of both. Okay, both equilateral and equiangular. Okay? That is a regular polygon. It has both all congruent sides and all congruent angles. Let's get into some extra practice down here. Here we go. It's our rule. They just have n minus 2 times 180. I did 180 times n minus 2. Doesn't matter. Multiplication is commutative. You can use it either way you want. Important note here. The sum of the measures of the interior angles of a quadrilateral is 360. That's not the one I'm talking about. We just talked about that. This one right here. Polygon exterior angles theorem. Probably didn't know this. The measure, or the sum of the measures of an exterior angles of a convex polygon. Doesn't matter how many sides the convex polygon has. The sum of each of those angles is 360 degrees. Okay, so it can be a 20-sided figure, but the exterior angles, all of them added up, is 360 degrees. So, what do we have to do here? We have to find the sum of the measures of the interior angles of the indicated convex polygon. Okay, so we're going to be using this rule. 180 times n minus 2, where n is the number of sides. An octagon, 8 sides, right? So 180 times 8 minus 2, which is 180 times 6, which, if you grab your calculator, it's equal to 1080. Okay? 15 gone. What is that? That's just a 15-sided figure. 15. Okay, so we have 180 times 15 minus 2. 180 times 13 is equal to 2340. Okay, and a 24 gone, right? 24 sides. We have 180 times 24 minus 2, which is 180 times 22, 3960. Why isn't that working? That's frustrating. The main eraser doesn't work. There we go. Hey. Almost done. In exercises 4 through 6, find the sum of the measures of the interior angles of a convex polygon. Or the sum, sorry, the sum is given to us. We have to classify the polygon by the number of sides. How do we do that? Well, we're still working with 180. That's n minus 2. Okay, but we want to find the sum of the we want to find the number of sides. So we don't know n. That's what we're trying to find. We're just trying to find n. So we can set this equation equal to 900. And then solve for n. We can solve for n. We divide by 180, divide by 180. We get 5, so n minus 2 equals 5. And then add 2, we get n is equal to 7. And if we went back up to our table, we know that a 7-sided figure adds up to 900. Sweet. Let's do that again. 180 times n minus 2 is equal to 1620. Okay, 1620 divided by 180 is 9. Add 2, we get n is equal to 11. Sweet. Last one. 180 times n minus 2 is equal to 2880. Okay? 2880 divided by 180 is 16, so n minus 2 is equal to 16. N is equal to 18. So it's a 18-sided figure. Right? That's what we're trying to find. We're trying to find the number of sides. Okay, last few. We want to find the value of x. So we want to use everything we've learned today to find the value of x. We know that this is a 4-sided figure. We know that a 4-sided figure adds up to 360. Okay, that's fine. If you don't know the number of sides or what it adds up to, you can always say 180 times 4 minus 2, because it's a 4-sided figure. That's equal to 360. Okay, so we know that 65 plus 95 plus x plus 45 add up to 180. Or 360, my apologies, 360. So, 65 plus 95 plus x plus 45 equals 360 degrees. Combine like terms. Okay, 65 plus 95 plus 45, that's equal to 205. So 205 plus x is equal to 360. And 360 minus 205 is equal to 155. All right. Same concept for h, or for 8. Count the sides. We have a 1-sided, 2, 3, 4, 5, and 6. So 180 times 6 minus 2. Okay, start with that. That's where we're going to set all of these angles. We're going to add them all up to what we get here. Okay, we're going to add them all up to what we get. I want to talk about number 10. This will be the last one I'm going through. Number 10. Remember, from up here, right here, the measure of the exterior angles of a convex polygon is 360 degrees. So all of these added up is 360 degrees. So if we solve this, we get 98 plus x plus 162 plus 4x equals 360. And if you did the math, 98 plus 162 is 260. So 260 plus, we have 5x is equal to 360. Okay, we get 5x is equal to 100 and x is equal to 20. Okay? Which is all we're asked to find, is just the value of x. So that's 7.1.